Welcome to The Explainer. I am absolutely thrilled to have you here with us today. So, we are pulling back the curtain on a massive, often completely hidden aspect of our modern world. We're looking at the fascinating, highly complex, and honestly, sometimes pretty daunting reality of chemical manufacturing. You see, the very systems that build our modern world also generate an absolute mountain of challenging materials. Today, we're exploring the cutting edge of how the industry is actually dealing with this, shifting away from that traditional gritty waste management and sparking what is really a circular chemistry revolution. To really wrap our heads around the scale of this, I want you to picture an invisible iceberg. According to the Sustainability Accounting Standards Board, or SASB, which you probably know sets the gold standard for corporate reporting, entities in the chemicals industry transform raw feedstocks into more than 70,000 diverse products. 70,000! We're talking about literally everything from agricultural fertilizers to the pharmaceuticals in your medicine cabinet and the parts in your car. These products are totally integrated into our daily lives. But here's the critical question. What exactly happens to the vast amount of byproduct left over from creating those 70,000 plus items? The tip of the iceberg is the product we all see, but the massive unseen structure lurking underwater, that is the hazardous waste generated in the process. Okay, let's dive into this. When chemical manufacturing takes place, it is an incredibly resource-intensive and reactive process. It inevitably generates highly hazardous process wastes. And we aren't just talking about, a bit of scrap cardboard or plastic packaging here. The daunting reality is that we're dealing with heavy metals, highly reactive spent acids, exhausted chemical catalysts, and these really dense wastewater treatment sludges. These are complex, dangerous materials that require extreme care to handle. As you can imagine, managing all of this creates an immense operational and regulatory hurdle. Because these materials are so hazardous, you can't just toss them in a standard landfill, right? Companies face incredibly strict, often overlapping regulations governing every single step of the process. They have to carefully orchestrate the secure transport, the specialized treatment, the highly monitored storage, and of course, the ultimate disposal. The sheer logistical complexity and the legal liabilities involved are absolutely massive, which makes waste management one of the single most critical operational challenges in the entire chemical industry. So, how in the world is this handled globally when different countries have vastly different laws? Well, this is where international frameworks step in. The SASB standard points directly to the United Nations Environmental Programme's Basel Convention. Think of this convention as the critical navigational compass for controlling the transboundary movement and disposal of hazardous wastes. In jurisdictions that might lack, say, comprehensive local environmental laws, companies use the Basel Convention as the absolute gold standard to define exactly what constitutes hazardous waste and how it must be securely handled. What's really interesting about this slide is how we measure accountability. The SASB Sustainability Disclosure Topics and Metrics draw a really hard line here. If you look closely at the metric coded RTCH 150A.1, you'll notice it focuses specifically on hazardous waste management. It requires entities to report two very specific numbers. First, the total amount of hazardous waste generated in metric tons. And second, and this is key, guys, the percentage of that hazardous waste that is actively recycled. It's no longer just about safe disposal anymore. It's about tracking exactly how much of this dangerous material is being kept out of the ground and put right back into the operational loop. And that brings us to a massive paradigm shift in the industry. We are drawing a hard line between basic, traditional disposal methods and advanced circular chemistry. Historically, managing this waste often meant dealing with gritty, automated warehouses stacked to the ceiling with industrial drums bearing hazardous labels, all destined for permanent disposal or just burning. Today, however, we are transitioning away from that and moving toward incredibly clean, high-tech recycling facilities. It's a profound shift, really, from simply getting rid of a problem to strategically recovering a valuable resource. So, the crucial point is how we actually define recycling in this new paradigm. The SASB standard lays out an explicit, incredibly important rule here. Materials that are incinerated cannot be considered recycled. It's kind of like burning your wooden furniture to heat your house. Sure, it serves a quick purpose, but you definitely haven't recycled the wood. Even if a facility uses direct incineration to burn combustible waste and recover the heat for energy, it does not count towards that recycled percentage metric. True chemical recycling requires a whole lot more than just burning away the problem. Let's look at what true chemical recycling actually entails in practice. It is a highly controlled, multi-step transformation. It begins at step 1 with waste generation, right there at the manufacturing plant. Step 2 is the highly regulated, completely secure transport of these materials. Step 3 is where the real magic happens, advanced chemical treatment. This is where those nasty heavy metals, the spent catalysts, and the sludges are systematically broken down and purified. And finally, step 4 is material reclamation, where valuable chemical components are extracted and prepped to re-enter the supply chain. It's a complete closed loop. Let's move to and see how this builds in a real-world application. Take spent catalysts, for example. These are critical, often super expensive chemicals used to speed up manufacturing reactions. But eventually, they lose their effectiveness and become, you guessed it, hazardous waste. But under the circular chemistry model, these aren't just thrown away. Instead, they are completely reused in new, perhaps less demanding processes. Or they are aggressively reclaimed to extract their highly valuable core metallic elements. In some amazing cases, they are entirely remanufactured back to their original state for the industry. This is what true circularity looks like, transforming a hazardous liability straight back into a valuable asset. But let's be totally clear about something. This transition is not just an environmental win. It is a hard-nosed, highly strategic financial decision. Direct disposal might seem appealing in the short term, mostly because it requires a lower initial investment up front. However, the long-term impact is a massive risk of remediation liabilities. I mean, you might be paying millions to clean up that waste years down the line. Circular reclamation absolutely requires initial capital to build those advanced recycling facilities. But the long-term impact? It fundamentally alters a company's financial future by creating a permanently lower cost structure. This brilliantly illustrates the core philosophy driving the industry forward right now. The SASB standard explicitly notes that effective waste management strategies, like recycling and recovery, quote, reduce an entity's long-term cost structure and mitigate the risk of remediation liabilities or regulatory penalties. Proactive waste reclamation just isn't a compliance exercise anymore. It is a literal financial shield. It neutralizes massive regulatory risks and potential litigation expenses over time, proving that good environmental stewardship is actually just excellent business strategy. We've seen today exactly how the chemicals industry is navigating the massive challenge of hazardous waste, from the strict tracking metrics of SASB all the way to the advanced reclamation of spent catalysts. The operational shift from direct disposal to a lower-risk, highly efficient circular economy is undeniably underway. But transforming an entire global industry that produces 70,000 different products doesn't just happen overnight. So I want to leave you with this to ponder. As regulatory pressures continue to mount and the financial benefits become basically impossible to ignore, how quickly will the broader industry adopt this circular revolution? Thank you so much for joining me on The Explainer today, and I really hope this sparks your curiosity to look a little closer at the chemistry that builds our world.